Okay, Honors Pre-Calc, I am not feeling the best today, and so I'm recording this for you for Monday, February 13th. And here is a few practice problems we're going to do in class. Then the teacher is going to pair you with a person sitting across from you, and you are going to have a little quiz that you're going to take in class, finish up for homework, and then the key will be posted after school today, and you grade it tonight as your homework to finish it and grade it with the key. Grade it honestly, and then drop it in the Dropbox. So that's the plan for today. So here is a few warm-up problems that I want you to do with me. So take out a blank Notability doc and start trying these problems with me. So first up, we're going to create a triangle that is a right triangle because we need to review those. The 30, 60, 90, you're supposed to know two ways to do this kind of problem. If I make this side be 14 right here, if it's a 30, 60, 90, I hope that this will not be too tough for you to figure out side Q. Okay, I'm going to give you a minute to try this without me, and then I'll have the teacher. Oh yeah, by the way, I'm going to also say I was wrong. Turns out we are going to give you a calculator on this next test, and so you should use your graphing calculators or borrow from the kid next to you. If Mr. Johnson wants to lend out my graphing calculators, they are in that closet up in the front, but he should definitely collect some collateral from you, like give him your cell phone or your keys on the desk so that he can make sure that he gets those $100 calculators back again at the end of the hour. So calculators are allowed, and let's round all decimals to two places. So if you were going to get an answer like this, let's say this was a 4, you'd say 1.75. So hundredths place. All right, so let's give you a minute or two and see if you can figure out the side Q here. Okay, so here's how I would have done it. I like to draw a little 30, 60, 90 triangle. That's the classic 30, 60, 90. A couple reasons I like doing it this way. It makes kids remember the 30, 60, 90 triangle because it's super important. And that's 1, 2, and square root of 3. And also, I don't have to use any trig. It's the one time during the trig unit that you can just go a proportion. Q is to root 3, like 14 is to 2. And then I can simplify. That's really just 7, right? And then I'm going to times both sides by root 3. Q's alone. Q is 7 root 3. Now, if you used a calculator to get that one, you just take your 7 and you would times by the square root of 3. So I'm going to do that here quick. And I got 12.12. So that's one type of question. Now, if you're a more strict traditionalist and say you have to use trig to do this, then I'd be thinking, if I'm going to use the 30-degree angle, then I have adjacent and hypotenuse. I hope you know that that's cosine. Cosine of 30 is adjacent over hypotenuse. Adjacent is the Q, the hypotenuse is 14. So then I can just go times by 14 on both sides. And I have 14 cosine 30. And cosine 30 is one of the ones that I should know from my 30, 60, 90 here. Cosine is adjacent over hypotenuse, so root 3 over 2. So this is really root 3 over 2. There's how I get 7 root 3. Okay, so that's one type of question you should have under your belt. The next one is, let's say that we have a right triangle again, but this time not a classic. So let's say this is 48 degrees right here. And because I told you two of the angles, you know the third one already. And let's say that this side is 11. This time you're pretty much going to have to use trig to set this one up. So keep in mind, if I were you, I'd use this 48 here. Doesn't require any calculations. And then I can just go sine, cosine, or tangent of 48. Oh, I haven't told you which side to get. Let's get this side right here. Let's call it M. All right, pausing for a sec while you guys give that one a try. Okay, we're back. So let's see. This one is going to be opposite over hypotenuse. So sine of 48 is equal to m over 11 times by 11 on both sides. 11 sine of 48. Typing it in my calculator right now. And I have, oh my goodness, I had a weird mode on. I had my radian mode on my calculator. The reason I knew is that I got a negative answer. And I was like, oh, that can't be right for a side in a triangle. 11 sine of 48 actually comes up to 8.17. If I was going to round it, 8.17. Okay. So I hope you're solid on those two. Those are kind of your basic right triangle trig questions. Now what if it's a right triangle, but I just want an angle? I know this is a right angle, okay? And this is 3 and this is 11. But how do I get this angle right here? This is where inverse comes in. Pause for a second while you guys give this one a shot. Okay, so you got to think sine, cosine, or tangent of this angle. And if I want the 3 and the 11, it's going to be sine of the angle is equal to 3 over 11. And then I'm going to do inverse sine on both sides. Inverse sine here and inverse sine here. That's a -1 if you can't tell. And inverse sine of 3/11 is 15.83 degrees. So that must be this angle right there. Okay, so that's just a reminder of how you can use inverse sine to find angles. Now, I want to review with you that deal where you have a triangle set up that could be ambiguous. If this is 10 and this is 50 degrees, and I have a side of 7, this is going to be called A. It could be any letter you want, but if I use this to be A over here, now if it's a certain length of side, then it would be exactly a right triangle, okay? And if it's bigger than that side, but not as big as 10, then it'll make the ambiguous case. And then there'll be two triangles that it could form. Okay. If it's bigger than 10 or bigger, either way, it's 10 or bigger, then it's going to have to go this way, and there will only be one triangle. All right, so that's kind of the setup for this type of question. So if I was going to do this one, and I told you that this is 7, but you don't know yet whether that 7 can swing both directions, or if it's actually straight up and down there, or maybe 7 isn't even big enough to connect. Like maybe you would need a little longer than that for the blue side to connect. So I'd like you to tell here whether or not with a number of 7 there, this makes a triangle that's a right triangle, or does it make two separate triangles, or is it possible that there are no triangles at all? So 0 triangles because the blue side isn't long enough, 1 triangle because it's a right triangle, and or 2 triangles. And I guess it's also possible if it had been bigger than 10 or bigger, it could have gone like this, and then there would also only have been 1 triangle. But clearly, that's not the case here. It's smaller than 10. So, all right, I'll give you some time. Work on this one. Okay, so here's how I've been thinking about this. I want to use the law of sines, all right, because I have an angle and a side across from it. So I'm going to go sine of this angle 50, and that's over 7 is equal to, well, I'm going to use this side of 10, of course. Okay, so I'm going to use 10, and then that must be sine of some angle on top. So we didn't name that. I'm going to call it B, though. Okay, so sine of B. And now, if I times both sides by 10, then I've got 10 sine 50 all divided by 7. Pause for a second while I calculate that. Okay, so the weird thing is that this comes out to 1.09. And so then I've got sine of b equals 1.09. And I hope some of you were like, when you did inverse sine and it says no solution, like you can't do that. Like there's no answer. I hope some of you were like, oh, I bet you this is the one where there is no triangle. And that is actually the case. Because if we go back and take a look at how long this side would need to be, remember I said it was 7. If you figure it for x and you go, okay, well, sine of 50 would be opposite over hypotenuse. 10 times sine of 50. 10 times sine of 50 will tell you 7.66 is the smallest that this could be. 7.66. So if I was telling you the side was 7, it wasn't big enough to even make one triangle. All right. And last but not least, let's use the law of sines in a more normal context. Let's say that this is 60 degrees, this is 50 degrees, and this side is 8. And I would like to know how long this side right here is. Let's call it P. Use the law of sines to figure out how long P is. Okay, so first step on this one. Sine, it is called the law of sines after all, right? Sine 50 over 8 is equal to sine 60 over P. I'm just realizing now that I set it up upside down. It would have been smarter for me to do it the other way. So I'm going to flip them. It won't take very long. 8 over sine 50 equals P over sine 60. See why you want to start with the variable in the first place and build it from there? Okay, so now I'm going to do 8 over sine 50 and times by sine 60. I'll pause for a second while I do that. And I got P to be 9.044. So technically I told you rounded 2 decimal places, so 9.04. There we go. So there's a good prep for your quiz that you're about to take that uses all of these skills. And you're going to finish that off at home after you've had a good chance to work with a partner on it in class. And when you get home, the key will be posted, and your only job is to grade it and Dropbox it. So set aside a few minutes to do that. All right, and that's all I have for you for the video for today.